Hello, students. Welcome to distance learning lesson number 4 for our Success Academy class. Here, we're going to work on Algebra 1 HH4, which is trig ratios, find a side length. Again, this can be found in the Algebra 1 content under HH4. Okay, so our last lesson, we were doing inverse trig. We are now back to using regular trigonometry in the calculator. Again, make sure your calculator is in degree mode. We'll check it when we go over to our calculator in a little bit. So right here, we want to find the missing piece. So remember our 3 trig functions. I'm actually going to just copy and paste them from above because I already wrote them just a little bit earlier today. So I'm going to copy. Remember, it is sine, cosine, and tangent. And with that, we have the acronym SOHCAHTOA. Okay, so our acronym is SOHCAHTOA. Don't worry, I'll post all of these completed notes in Google Classroom. So remember, sine of our angle is equal to the opposite side over the hypotenuse side. The cosine of my angle is equal to the adjacent side over the hypotenuse side. And the tangent of my angle is equal to the opposite over the adjacent side. Okay, so here's what's really cool. I have 1 piece of information, 2 pieces of information, and 3 pieces of information that all go along with sine. Same thing with cosine and tangent. So we really have 3 pieces of information, but they didn't give us 3 pieces. They only gave us 2 pieces. They gave us this piece here, 8. They also gave 22 degrees as one of my pieces of information. So they want me to find TU. So here's how I'm going to start this question off. I'm going to put a variable there. Now I have 3 pieces of information, but one of them is an unknown. The question now is, what trig function is the relationship that's given? So look at, let me label this side as my hypotenuse. Let me label this side as my, look how far away it is. That's going to be my opposite. And then this one that makes it up is the adjacent side. I don't even need to, whoops, it's doing that again. Oh, it's doing that again. All right, I don't need to use the adjacent side because the only 2 things that I need to focus on are the opposite that's unknown and the hypotenuse. Okay, so in terms, again, of angle V right here, in terms of 22 degrees, because that's what they gave me, we have an opposite side right here and a hypotenuse side that I'm going to work with. So that function is the sine function. So I'm going to say sine of my angle is equal to opposite over hypotenuse. So the sine of my angle, 22 degrees, is equal to opposite, which is x, over 8, which is the hypotenuse. Notice all I did was substitute in the pieces of information that I knew and the variable as well. Now let me ask you, how do you solve for x by itself? Well, we are going to multiply both by the number 8 because that will get rid of the 8 in the denominator. So right now I have 8 times the sine of 22 degrees, and that is actually equal to x. Awesome. What we need to do is we need to get an approximate value in our calculator. We need to actually do that workout. They want it rounded to the nearest tenth. So I'm gonna go to my calculator. I need 8 sine of 22. Okay, so 8 sine, oh, I'm right there. 8 sine of 22. Let's make sure we're in degree mode. I'm going to check real quick. Sine of 30. Yep, good. Cosine of 60, good. Okay, I need 8 sine of, what was it? 8 sine of 22 degrees. So I'm going to type that in, 8 sine. Notice I'm not using inverse. I'm just using regular sine because we're not looking for an angle measure. We're looking for a side length. And that is 2.99685. 2.99685. 2.99685. And we are now going to round this up to the nearest tenth. So that's going to give me x is approximately equal to 3.0. We could even say x is approximately equal to 3. Those are both results. Those are both answers. Whoops. All right. Oh, I don't like how that keeps moving. All right. So TU is 3. Or we could say 3.0. All right. That was our first example. Again, substitute in for what you know, and then solve for x. Okay? Next one. This one is another sine one. I'll show you why. Here's CD. CD is unknown. Wants me to solve for CD, right? That's what it's asking me to do. So I'm going to do the sine of 59 degrees is equal to the opposite side. Wait, let me do general. Sine of angle C, sine of, I do above. I want to be consistent. Sine of my angle, sine of my angle is equal to the opposite over the hypotenuse. And that's what they gave me. They gave me the sine of angle C, which is 59 degrees, is equal to the opposite side, 5, over the hypotenuse side, x, because the adjacent side wasn't used at all. I'm not going to put a variable there because I don't want to even know what CE is. I don't really care because the question's not asking me for that. Okay? So now the question is, how do I solve for x? The first thing you have to do is move x up to a numerator. So you're going to have to multiply both sides by x, which will get out of the denominator. So you'll have x times sine of 59 degrees equals 5. And then the second step is going to be to divide both sides by the sine of 59 degrees. It's not dividing by 59, it's the sine of 59 degrees. Okay? And what that does is it kind of wipes that out, and you now have x is equal to 5 divided by the sine of 59 degrees. Okay? Here's another strategy. If you get really good at this, think about your cross products. Think about how these are cross products. You would multiply them, and it doesn't matter how you multiply them. So you could literally move x up here and then move sine of 59 down there, and that's a totally legal operation. You just switch them. You can switch anything on the diagonal, okay, because you're multiplying them anyway. So quick switch, move denominator to a numerator on the other side, move a numerator down to a denominator on the other side. Okay, but we actually have to do the work now. So now x is approximately equal to, and I'm going to do in my calculator 5 divided by sine of 59. Was it 59? Yep. I'm going to hit enter. And so my side length, the variable I found, is 5.833, 5.833, 5.833. Last step is to look at this 100th place and round appropriately for my 10th place, which is going to round off. It's going to round to 5.8. So my answer for CD is 5.8. Notice this one was a little bit more difficult because of that x I had to solve for. I had to move things around. So I'm going to do 2 problems of each, okay? I'm going to do an easier one where you just have to multiply both sides by a number. And then I'm going to do one where x is in the denominator and you have to move it around, okay? So the next one here is actually the cosine function. Let's look at the cosine function. So here is x. It wants to know what ij is. That's what the question is, okay? So I'm going to say that, let's look at the opposite side here. That's your opposite. This is always my hypotenuse because always opposite the right angle. And then the adjacent side. Well, I don't need the opposite right now. So I just need the adjacent side, which is what makes up the angle, not the opposite side, and the hypotenuse. So the cosine of my angle is equal to adjacent over hypotenuse. So the cosine of 49 degrees equals x over 8. And then we're going to multiply both sides by 8 to get 8x by itself. So 8 times cosine of 49 degrees equals x. And so I'm going to say x approximately equals. So I'm going to type in 8 cosine of 49. 8 cosine 49. 5.248. 5.2. Don't forget, focus on this number here because it wants it to the nearest tenth. So go to your 100th place, and this one is going to actually round off because the 4 will not round up. Okay, so 5.2. Good, good. Another cosine one, this one a little bit more difficult. So we're going to say the cosine of my angle is equal to opposite over hypotenuse. Now, how do I know it's cosine? Well, because ST is unknown, and the angle in question is angle S, which is 23. So I'm going to do the adjacent side. Look how close that is. There's 2 adjacent sides always, but one of them is adjacent because it's the hypotenuse, because the longest side. So I just want to make sure that I identify the longest side here as being the hypotenuse, and then the other one's the adjacent. Okay, so I'm going to do the cosine of 23 degrees equals the opposite side. Oh, I'm sorry. It's adjacent. It's adjacent. We were just doing opposite. Adjacent over hypotenuse. My apologies on that. If you were confused, I hope you caught back up and you understand. I wrote the wrong trig function. So cosine is adjacent over hypotenuse. So it's going to be 7 over x. You have to solve for x. So we're going to first multiply it by x. Multiply both sides by x. So x times cosine of 23 degrees equals 7. And now we are going to divide both sides by the cosine of 23 degrees. Let me move this so it makes more sense. And then we have this that's happening. So x equals 7 divided by cosine of 23 degrees. So x approximately equals 7 divided by cosine of 23. is 7.604, 7.6045, I think it was, 5. Yep. All right. Look to, what color haven't I used? I've kind of used all of them. I didn't use orange. Good. Look to this decimal place because we're doing tenths. So we go to the 100th. We realize that it rounds off to 7.6. All right, so that's a difficult cosine one. You had an easy cosine one and a difficult one. Now tangent, I kind of left this, I've already put them in order for us. So let's do tangent. We want QR, and here's the hypotenuse. It's always the hypotenuse. In this case, I'm given the opposite and the adjacent. And I was never given the hypotenuse, even as a variable. So we're going to do the tangent. The tangent of my angle is equal to the opposite over the adjacent. So the tangent of 27 degrees is equal to x over 4. Multiply both sides by 4. So 4 times tangent of 27 equals x. And we're going to get x approximately equals, so 4 tangent 27 2.0381, 2.0381. And we're going to now round it. It rounds off, so x approximately equals 2.0. You don't need to write it as 2.0. You can write it just as 2 if you'd like. All right. Now, if I'm going too fast, just pause the YouTube video, and then you can do these one at a time. All right. So I just want to keep it less. I want to make sure that you have enough. You're not watching this for. Okay. All right. The next one, I included another tangent one. So let's see. We have IJ we're looking for. And so here's my hypotenuse. This is my opposite side. This is my adjacent side. Think about adjacent being near it, right? It's what makes up angle J. There's two adjacents. This angle right here is made up of JK and JI. So that JK is the side that's adjacent and JI is adjacent. But don't forget, JK is the special adjacent. It's the hypotenuse. It's the longest. Okay? So we're going to do the tangent of angle X. The angle is opposite over adjacent. Tangent of angle of 36 degrees equals 5 over x. Now multiply both sides by x to get it out of a denominator. So you get x times tangent of 36 degrees equals 5. And then we're going to divide both sides by tangent of 36. So we get x is equal to 5 divided by tangent of 36. Okay. I just want to clean that part up before I move on. Times x. You just couldn't really see it. Okay, so x is approximately equal to 5 divided by tangent of 36. And we're going to get 6.8819, 6.8819, 6.8819. And we're going to round. That 8 is going to bring it up to 6.9. 6.9. Now take a look. So far, all my answers are reasonable. 6.9 compared to 5. That's pretty good, right? 5 and 6.9 are similar. 4 and 2 are when we're talking about, the smallest angle being across from the smallest side. So 27 degrees is my smallest angle. It's across from 2, my smallest side. 7 and 7.6, those are reasonable. 8 and 5.2, yep, those are reasonable because it's shorter than 8. 5.8 is reasonable because it's hypotenuse and the longest side appears to be 5 other than the longest side, which is the hypotenuse, 5.8. Here, 3 and 8, those make sense because it's got to be shorter than it. Whoa, I don't know what I just did. That was crazy. I've never seen that before, that toolbar. Okay. Yeah. So now I'm just going to do one more problem. And it's because it's a radical. But don't be afraid of this, okay? Let's look at this one. It wants PQ. So right now I'm going to put in an X for PQ. The question is, what trig function? Well, let's take a look. PQ. This appears to be my hypotenuse, so it's going to be either sine or cosine, okay? This appears to be my adjacent side. Look how close it is. And then this is my opposite side that has nothing here, okay? So we're not using the opposite, we're using the adjacent and the hypotenuse. So if we're using adjacent and hypotenuse. So what does that mean? That means that we're going to be using the cosine function. So cosine of my angle equals the adjacent side over my hypotenuse side. So it's going to be cosine of 55 degrees is equal to, okay, let me change that because now I'm actually evaluating it. So the cosine of 55 equals adjacent, square root of 11, over unknown hypotenuse. So now you're going to multiply both sides by x. So x cosine, x times cosine of 55 degrees equals the square root of 11. And just like you did before, divide by cosine of 55. Cosine of 55. And you get x is equal to the square root of 11 over the cosine of 45. Now, just type that in your calculator. The square root of 11 divided by, this is on Google as well, so you have everything you need. This calculator is a Google calculator. I'm just going to do the square root of 11. Make sure I use parentheses. Make sure that it stays as just the square root of 11. Divide by the square root of 55. And we get 5.782. 5.782. X approximately equals 5.78. One more time. 78235. Okay, 235. And what we do want to do is we want to round. So that 8, it's to the nearest tenth, so it's going to be 5.8. It's going to round it up to 5.8. Okay? And that's the end of lesson 4. It's a longer one, but lesson 5 will be kind of quick. Okay? So good luck, and ask us question in our Math Live sessions or book an appointment. Okay, thank you. Good luck.